Okay, so binomial probability. Today we're looking at some more complex problems when it comes to binomial probability. We'll also look at how we can use our calculator to make this binomial probability stuff easier. For those of you who are interested in when these videos get made, it is now 6:04 p.m. Just come back from a run, and I figure I've got about 26 minutes before some of you guys get started on your homework. So I'll try to get this done, uploaded before 6:30 so you guys can get started on it. Okay, so to set this up, we've got a spinner here. You can see that a quarter of the spinner is yellow, the rest of it is blue. Spin the spinner 6 times, graph the probability distribution of getting yellows. So we can just assume that if the spinner lands on yellow, that's a success. You win a prize of some sort. And we're going to spin this spinner 6 times. Now, when we graph this probability distribution, we're going to graph it on axis like this, and it should be straight, obviously. We need to know the probability of getting 0, 1, 2, 3, 4, 5, or 6 successes. So we need to know the probability of getting all of those. Now that's going to be really tedious to do 7 different sums, because you'd have to use your binomial formula. That is Px equals x equals NCx p to the nq to the n minus x. You'd have to use that formula 7 times, once for each of those things to graph this. That's going to take way too long. So I'm going to graph this using my graphics calculator. Let's get it out and see how it works. Now here's our calculator. I'm going to show you how to use that formula on your calculator in a really fast way using stat mode. So first of all, go into stat mode over here. Now we're looking at the binomial distribution. So we press this distribution button. And there's all sorts of probability distributions, a lot of which you'll learn in university next year if you do a stats course. We're looking at the binomial distribution here, so F5. Now, for the time being, we'll learn about BCD in a moment. That's cumulative distribution. But this is what we're interested in, BPD. Okay. Now, first of all, make sure that it's not set to a list. Make sure it's set to variable there. You're going to set it to, first of all, x, which is the amount of times we want success. I'm going to set it to 0 because I'm going to draw that one first. The number of trials, we're going to have 6 trials. And then the probability of success. Now remember, success is getting yellow here, so I'm going to put that to 0.25. And then I'm just going to execute that. Alright, so really simple. It says that the probability of getting 0 successes from 6 spins is 0.178 when I round it. Okay. I'm just going to go back a bit. Now this time I'm going to check out 1 success. Execute that. Now the probability of getting 1 success, is 0.356. I'll graph this in a minute. Back. Okay, you're getting the basic idea. Probability of getting 2. 0.297. I'm going to do the rest off camera, just wait. Okay, you can see I've done all of my values here now. Time to get down to graphing. Just before I do that, you can see that the probability of getting 6 successes from 6 trials on this spinner is 0.0002. That's like 2 in 10,000, so not very likely. Anyway, let's graph this thing. Okay, so we've graphed the probability distribution here now. You can see that there's about a 35% chance that you're going to get 1 yellow if you spin this 6 times. there's about a 30% chance that you'll get 2 yellows. So those things, and that's where we're going to head to next with our probability. So far we've done two things. We've graphed a binomial probability distribution, and we've also learnt to use our calculator to figure out a binomial distribution for any one of these things. We're not finished with this complicated stuff, so we're really just getting started on it. Okay, so a couple of questions here. Find the probability of more than 3 successes, so more than 3 yellows. So that's the probability. Oops, I'll use a different color there. That's more than 3 successes, so the probability that x is greater than 3. That's going to be equal to the probability that x is equal to 4 plus the probability that x is equal to 5 plus the probability that x is equal to 6. I'm going to show you two ways to figure that out. One way, I'm not going to run through it, but one way would be to do the formula for this, the formula for this, and the formula for this. So 3 formulas, one after the other, add them all together. Now obviously we can just look at our binomial distribution here, and we can see that the probability that x is equal to 4 is 0.033. We can see that the probability that the distribution is equal to 5 is 0.004, and then finally we can see this one is equal to 0.0002. Now if I add all of that up together, I should get 0.0372. So there's a 3.72% chance, that's 3.72%. There's a 3.72% that I'll get more than 3 successes. Now this question is related here, less than 4 successes. So less than 4 successes means 0, 1, 2, or 3 successes. Now again, probability that x is less than 4. Again, that's equal to the probability that x is equal to 0, plus the probability that x is equal to 1, ... plus the probability that x is equal to 3. Again, we can add all of them up. 0.1, I promise I'm getting to a point here, because I know at this point you're thinking, this is really easy. 356 plus 0.297 plus 0.13. Okay, and you can see that that's equal to 0.961. So you're really likely, you've got a 96.1% chance that you'll get less than 4 successes. Now I've set this question up on purpose, and some of you who have done some questions today will already see what I've done. These two answers are related. When you take those two numbers, they should, in theory, add up to 1. That's because this question deals with more than 3 successes. That's all of this stuff from here onwards. And this question deals with all of that stuff. And within a binomial probability distribution, all of these values should add up to 1. Now, if you type that into your calculator, you'll find that I'm lying to you. They don't add up to 1, but they add up to something really close, 0.998 something. That's just because of rounding errors. We've had to round each of our numbers. But in theory, the probability that x is greater than 3 should be equal to the probability that x is less than 1 minus the probability that x is less than 4. These added together are equal to 1. That's the major upshot. That's important news for us, because if we get a question like this, and you'll see this very often with this at least thing, it makes our life very simple, because a lot of people are going to be tempted to say, okay, I need the probability of at least one success. At least one success. So that's the probability of this plus this plus this plus this plus this plus this. Much faster way to go is to say the probability that x is greater than or equal to 1, which is what at least one success means. The the probability that x is greater than or equal to 1 is equal to 1 minus the probability that x is equal to 0. All of a sudden, we have a question that we can solve really, really fast. 1 minus the probability that x is equal to 0, 0.178. And so this is what we want, probability of this occurring. So all we do is 1 minus the probability of this occurring. And that gives us 0.822. Okay, there is one more little thing I want to show you here. It's on your calculator. So last time we jumped into your calculator, we were in stat mode. And we went to the distribution because we were dealing with binomial distribution. So we went to the binomial distribution and we were faced with this. BPD or BCD. Now BCD stands for Binomial Cumulative Distribution. I'm going to show you this, how it works. I'll leave you guys to think about the applications for it yourself. Now when you press the variable button, it looks very similar. It looks identical to the last time we used binomial, but instead of saying PD, it says CD. Let's take a look. If I put an x value of 2 and the number of trials 6 and the probability of 0.25. Now, a lot of us will think that that says that I want 2 successes from 6 trials and the probability of success is 0.25. That's not what it says. Let's see what it returns as an answer. It gives us a probability of 0.83. That's much higher. Remember, it said 2 successes from 6 trials. 2 successes from 6 trials looks like 0.297. But our calculator just told us it was 0.83. What the binomial cumulative distribution tells you is the cumulative probability from 0, from the start of the probability distribution, to whatever number you asked for. So when I typed this into binomial cumulative distribution, I was actually asking what is the probability of 2 or less successes. And you can see if you do 0.178 plus 0.356 plus 0.297, you should get something very, very close to 0.830, which is the probability of getting 2 or less successes. Okay, it's now 6:31. I'm going to hit stop here. I'm going to upload this video to YouTube. It'll be up on your document shortly, and you'll be able to do some questions once you've watched it. Thanks, guys.